This video shows the simulation of the depressurization of a CO2 N2 mixture from a pipe following a full-bore rupture. This case is derived from the following article. Munkejord S.T. et al., Depressurization of CO2 N2 and CO2 He in a pipe, Experiments and Modeling of Pressure and Temperature Dynamics, International Journal of Greenhouse Gas Control, 2021, 103361. Experimental work was performed at the Xpsim depressurization facility. Xpsim is the European research infrastructure for CO2 capture, utilization, transport and storage. www.eccell.org. The experiment was made using a pipe 61.7 m long, of 40.8 mm internal diameter where the fluid was initially filled at 120 barg and at a temperature around 20 degrees Celsius. The depressurization is completed in a time period lower than 10 seconds. The simulation is performed using an initial time step of 1 millisecond, the minimum time step is set at 0.0001, and the maximum value at 0.02 seconds. Using Xpsim, this case is reproduced with high precision and is one remarkable verification of the capabilities of this software. The input file is open. The process flow diagram shows the pipe PL1 equipped with piping and valves for the filling of the fluid and its containment. Let's have a look at all input statements required to set up the simulation. 3 components: nitrogen, helium and carbon dioxide are defined. Coibent and steel materials for the pipe wall. Some instrument limits. The feed stream for pipe filling. Pipe segments are defined as 0.5 meters long. Full-bore rupture event is defined as a leak at the time of 1 second of the duration of 2 milliseconds. Instruments to get pressure, temperature, velocity, liquid holdup fraction, and flow pattern are defined at some pipe positions. The total mass, liquid mass, and vapor mass are also measured. Initial pipe conditions are also reset. The instrument's trend is shown in a 30 seconds interval. Calculation time steps are defined. The simulation is started and the plant view interface window is created. Calculation stops after initialization at time 0. And after the first integration step, in this case of 1 millisecond. The user moves into the trend view and restarts the calculation. We should remember that the pipe rupture happens at 1 second. Let's go back to the trend view. The user gives a new look at the instrument trends for the 8 groups. When the simulation reaches the time of 10 seconds, it enters a wait state. The simulation is then stopped by the user. The main window is reopened. The view of the graph list is open. The internal pipe data registered each second are browsed. These graphs are followed by those of the instruments defined by the user. At the pipe's initial point. After 1 meter. After 10 meters. After 20 meters. After 40 meters. At 60 meters distance. At bore rupture. The fluid mass contained. The liquid and vapor fluid compositions. All graphs can be saved as a graph collection in a single file, as already shown in other videos. The user can reopen the graph collection to extract any graph for further customization or to export its data to Excel.